Okay, so we're going to do a little problem solving with trig. They've given us a question. There is a triangle. The triangle is x, y, z. Okay, so we've kind of drawn a sketch of just a random triangle x, y, z. Doesn't matter if I put z here, y here, and x. We have to follow the way to actually measure all the sides and angles from what they've given us. So side xz, that would be considered this side here. Okay, from point to point, is 13 millimeters in length. So this side is 13 millimeters in length. Side ZY, which is here, okay, is 17 millimeters in length. And then angle X would be right here at 65 degrees. So, if we're confused with the 2 points telling us the side, we can always just call this side X, this side Y, and then our other side as side Z. Okay. And the question says to find the other 2 angles and the missing side. Now looking at this, we think, do we use cosine or sine ratio? And remember...
So you need another m besides the 17.
I need another m? Oh, sorry. With sine law, the best way to set this up is if we have an opposite side and angle. We know we can use sine law. And if we can use sine law, it's usually a little faster than using cosine law. So because I have an opposite side and angle and then another known part on the triangle, we're going to use sine law to solve this. So we'll set this up, and instead of calling it ABC, we'll call it sine x over side x is equal to sine y, actually usually these are in capital, over side y, and then sine z over side z. Okay? We'll plug in the information we have here. Side x was our 17 and 65. So we have sine 65 over 17 is equal to sine y, which is unknown, we don't know the angle, over side 13. And then sine z, we don't have any information about. So the very first thing we're going to do is solve for the unknown angle. Once we have that unknown angle, we'll have 2 angles of a triangle, and we can subtract from 180 to figure out the other angle. And then use sine law again to solve for z. So we'll just focus on this ratio here. So, and the reason we're using sine law and not one of the primary trig ratios is we have no idea if either of these angles are 90 degrees, so we can't assume they are. Okay? So with sine law, we set this up. We have sine 65 is equal to 17, which is over 17 is equal to sine y over 13. The goal is to isolate y. So I'm going to show you how to do this all so you can do this in one step on your calculator. I only really need to bring 13 over to the other side, which means it's multiplied. So it'll become 13 multiplied by sine 65 divided by 17 is equal to sine y. And because we're trying to isolate y, we can bring sine to the other side. When I bring sine to the other side, what does it become? So sine inverse, we'll put a large bracket around this. 13 multiplied by sine 65 over 17 end bracket is equal to y. So you can do this all one step on your calculator. Mine's not as good as hopefully what yours is, but let's go with this. 65 sine divide 17 times 13, and then the inverse of sine 43.8. So our angle y is 43.8. So let's go to y is approximately 44 degrees. Okay. So this y here is 44 degrees, which means we can just take 180, because we know a whole triangle adds up to that, and subtract 65, and then subtract 44 from there to find out what the unknown angle z is. So angle z will equal this amount. So let's do this here. 180 subtract 65 is going to give us 115. 115, and when we subtract there, we're going to get 171. Is that right? Yeah. So then our angle Z is 71 degrees. Now that we have that, we have information that we can plug in here to find the side. So I'm going to use the original side we didn't know, sine x. We'll kind of do that on the side here. Okay. So set up our sine ratio again. But I'm going to show you a trick here. I have sine 65 is equal to, or sorry, divided by 17 equals sine 71 divided by z. Because these are equivalent ratios, I can just flip this ratio, okay, and keep it equal. So let's now change it to 17 over sine 65 is equal to z over sine 71. And the reason I do that is it's easiest to actually isolate the variable when it's on the top of the fraction, okay? So it's on the top of the fraction now. All I have to do is bring sine 71 to the other side. So this now becomes sine 71 multiplied by 17 divided by sine 65 is equal to z. And again, we can try that in our calculator. Actually, mine might have difficulty with that. 17 divide, and I'm going to have to put brackets, 65 sine, and bracket, equals, okay, and then times bracket 71 sine, and bracket, equals 17.73. Hopefully that was done right. So we can say approximately 18 if we really want to round it. That's kind of a poor rounding. It's better if we would go 17.77. Okay? So the other unknown side is 17.7. Yeah, and that makes sense. And the reason this makes sense, okay, I want you guys to compare to opposite angles and sides right now. The largest angle is 71 degrees, which means the side opposite it must be the longest side of the triangle. And this one, from what we found, is. The next largest side is 65, not much smaller than 71. So that opposite side of the triangle should be a little bit smaller than our side Z, which it is, 17. And the smallest angle is Y, which means that should be the smallest side on the triangle. Okay? So you can use logic to make sure your answer makes sense after you've carried everything out.